Stars must also receive their food and fuel from the larger world that they live in. That's just the plan.
You are listening to And If Love Remains.
Speak peace like a Buddhist.
A unique show spotlighting people, ideas, science, culture, and art. Your host, Mike Lovett.
Yes, you're listening to that great podcast in the sky, And If Love Remains, and I am its humble messenger, Mike Levitt, and I am very excited to have on today Dr. Michael Clarage. I have to say before I get into who he is and what he's doing, he's one of those guests that I've been itching to ask to come on. Obviously, I've been a little bit nervous because I just think he's such a smart guy, and I love having smart people on. So I appreciate having him on, but I love his work. I love the things that he's doing. He has a BA from Carleton College in Minnesota and a doctorate in physics from Brandeis University in Massachusetts. He has done research in radio astronomy, protein dynamics, and the calculus of fractals. He has had successful careers in the restaurant business, designing large email systems and creating secure cell phone messaging for healthcare. In 2012, he became active in the electric universe, contributing to studies of the interstellar medium and current flow through space. He is currently an educator and principal investigator on the SAFIRE Project. Dr. Michael Clarage, thank you so much for being on And If Love Remains.
You are so welcome. It's very good to be here.
It's very good to have you. And before I begin, I just want to encourage anybody, if you're at all interested in what we talk about today, I'd highly encourage, number one, check out his Substack, Michael Clarage, on Substack. We'll put links, and also check out his work with the Thunderbolts Project on YouTube. I love his video essays. They're really well thought. They're beautifully done, and I think they'll be they're mind opening. They have been to me. So please check them out on those two venues. I want to start in just a little bit of background, but I have to say one of the things that popped out to me is your study in the calculus of fractals, because I am fascinated by fractals.
Yeah.
I think they're so interesting and fabulous. Just tell me a little bit about that and what you did and why that interests you.
Yeah, that started hard in college. I have a brother who's 1 year older, and he was at college in Illinois. I was in college in Minnesota, and we both kind of, just woke up to this field of fractals, and studied the available. So this is in the mid '80s, and there wasn't that much available, and it was so obvious that the physics we were learning, was all based upon Euclidean geometry and calculus, linear algebra, and that whole realm is absolutely useless to describe living fractals. Just useless. And that was such a shock to me to realize that. I don't know if you may have heard that Newton's mechanics only works for two-body problems. So you can only solve where, like, if the Earth was the only planet around the sun,
right,
you could solve for it. But it cannot solve for a three-body problem. And when you first learn that as a physicist, you're like, wait, whoa, wait, what was that you just said, right? Because of course we live in a universe of more than two bodies, right?
Yeah, multi-bodies.
Multi-bodies, and the solar system, multi-body. So it's kind of understood, but it's a question mark. Why? What are we supposed to do with that? That the way that we all study physics and mathematics, by its own admission, or by an obvious, it's incapable of describing anything more complicated than two. It can count up to two, right? So this whole realm of fractals, I and my brother were going into it like there's got to be some way to turn this into a physics. There's got to be some way to make physics out of this, to make mathematics out of this. And so that was what led us into it. And we had plenty of intuitions, but actually very little like mathematical, physical results that we could pass on. So I'll just say one of the things that we were clear, but couldn't like publish papers on it, is that the fractional dimension of the object depends upon what kind of energy it is transforming. So for example, your lungs have a different dimension, fractional dimension, say, than the inside of your ear canal, or the way that your nose is designed, or the way that your blood vessels are designed. And this whole thing about how can something have a fractional dimension, we all see it. We see it constantly. If you look at a tree, if you look at a picture of the blood system, if you look at rivers, those are fractals, and they're not lines, and they're not planes, and they're not solids, right? If your lung was a solid, you couldn't live, right?
Right.
So nature does this thing where she has built in these fractional dimensional objects, which are not lines or planes or solids, but somewhere in between. And then the details of what dimension in the case of the lung is designed so that it can take air from outside of you and make it air inside of you. I mean, it's pretty amazing, right?
Yeah.
We have air in us. The gas gets dissolved. So there's air outside of us, and then there's air inside of us. And the lung is what is the geometry that you need. I mean, of course, there's chemistry involved, but I'm just saying the geometry of the lung is what you need to make that transition.
That is fascinating. That is really interesting because, and it does speak to kind of this bigger world of what often we think of scientists as they know so much, or we know so much about the world and our bodies and the universe around us. And then we ask like a simple question, like, how does this work? and it can't be answered.
No, not at all. It's literally like a face plant. Sorry. No, I have devoted my life to science. I don't want to badmouth it. I don't badmouth Newton. I don't badmouth Einstein. These are my heroes. But you just have to acknowledge like the limitations of the field.
Right. And there is a lot of truth to the more that we know, the more we realize we don't know.
Yeah, exactly. Yeah.
So, and that kind of takes me to kind of, the main reason why I asked you to be on, which is this just fascinating community, this interesting, I really think it is, I'm not a scientist. I'm a crazy musician, but the more I look into it, the concepts of plasma, the electric universe, the ideas that are so transformative and enlightening. I tell you from my perspective, when my father, who's an electrical engineer, I think I mentioned to you, he's the one that turned me on to these ideas. And before I started looking into it, the universe seemed such like a dead, empty.
Well, yeah.
It was just like void, and what's the purpose of these rocks? And like, it really is. It can get depressing if you really think about it hard. And then you read things like C.S. Lewis's The Space Trilogy and how alive that world is. It's a crazy universe that he creates, but it's alive, and it's there's angels and there's things and it just once I started researching the electric universe, I felt that aliveness again. I felt, wow, these are incredible ideas, and it makes space exciting.
Yeah. Yeah, exactly. Me too. I left. So when I left Brandeis, it was clear that I was not going to be able to continue in that realm by pursuing the questions I wanted to pursue. And I didn't understand this. I think a lot of graduate students don't understand this. It's very rare that you get to explore what you want and get paid for it. That's pretty rare, right?
Yeah.
And so the options were kind of like limited, and in the climate, or I don't know when it got established. It used to be, I read this somewhere. It used to be that in the 1800s, you were expected as a graduate student to have research that had nothing to do with your advisor's research, and in fact, all the more power to you if it contradicted your advisor's research, right? That was
Right.
the way you proved yourself. You went out there and you fought, and you went up against it, and and then something happened. I don't know, after World War II, I think, where it was just the opposite. The way you succeed is by falling in line with your advisors and the people around you. And so the options were there, but had nothing.
Well,
Not what I wanted to look at.
especially in today's environment, I mean, that's where all the funding is. That's where all the money is. And if you want to get paid,
Yeah.
that's where you have to go.
It is. And so for example, I was starting to study material about, outside of graduate school, I was studying material about, like, how is it that a cell is a independent living thing that's then part of a larger world, right? And our bodies are these independent living things that are part of a much larger world. And and then the earth is this independent living thing that is part of a larger world. And I was like, we have to study this, because this is going to be how we understand the universe. And I was told, the exact words were, Michael, you're asking the wrong questions. I don't think you belong here. And so that was very painful for me. It was very painful. Yeah. And so I went to work in the restaurant business for 7 years after that, after I got my PhD. Yeah.
Yeah. Well, and I think it's really interesting that you say that, because one of the questions I think that you mentioned that scientists need to ask, when they discover something or when they find something interesting, is what is the function of what's going on?
Exactly.
And they aren't asking that, are they?
No, the biologists are way ahead of us in that regard. And then, as soon as you try to ask, well, what's the function of the ionosphere? And it's like, oh, whoa, what do you mean? What's the function of the ionosphere? I'm like, yeah, what's the function? What's it doing? What's its job, right? Otherwise, we are never going to understand it at all.
Right. Right. And in some ways, it goes back to kind of the ideas that you're exploring in with fractals, because everything has to work all the way up and all the way down.
Yes. Right.
And
Otherwise, there's a break, and you know what? There are no breaks in the universe. So,
that speaks to something. Like, there are no breaks. There are no, everything serves a purpose for a higher or lower entity.
Yeah.
And
so getting back to your comment about the electric universe, same for me. When I started to understand what was going on in that field, that delightfully chaotic community called the electric universe community, stars, just like we receive our food and fuel from the larger world around us, and the sun, the earth literally receives all of its food and fuel from the sun, stars must also receive their food and fuel from the larger world that they live in. That's just the plan. And so it was very obvious that the electric universe paradigm nailed that one. That's built into it, is that stars, well, just like we take in energy, but also in a strange way, I don't know if it's the right way to say it, we also make energy. So it's kind of like we're energy transformers.
Yeah.
I was looking at the dragonflies. There's a lot of them this year for some reason out here. And I couldn't even imagine that they could eat enough bugs to do all the stuff they do all day long. They're just going all day long. And I didn't even see you eat. Did you even eat anything? Right? So there's some mystery about how much energy is in the universe. So sorry, I got a little sidetracked there. So the sun has to receive its energy from the larger world it lives in, but then it also transforms it, just like you and I transform broccoli, right? That's just the plan. That is
right.
The plan.
And what were some of because obviously we're all taught in school that the sun is a big nuclear bomb in the sky.
We're taught that it's lonely too.
That's right. We were taught that it's only that all this is an accident, that gravity has somehow magically put this solar
Yeah.
system together, and there's no influence at all other than the accident that things happen to spin in the right direction, and
Yep.
it's a bunch of magic when you really think about it. But what for you, because we all come from that paradigm, what was maybe some of you mentioned the idea of a star being fed from outside. What are some of the evidences? What were some of the things for you that really kind of locked that into place and thought, these guys really are on the right track?
Yeah. Yeah. Great question. Right. So while you're calling that up,
Yeah.
I'll say that so the cosmology of the electric universe is so much more satisfying than the cosmology of gravity and lonely stars. And so that was kind of, something deep in me, and others just recognizes that. And then you start to scratch a little bit at the nuclear fusion model of the sun. And you start to realize, whoa, there's very little evidence. And then you bring it up, like I did at an astronomy symposium, right? And you get descended upon, right? The claws come out, and you get run out of town, and everybody's just like, oh no, it's the science is settled,
Right.
and then, but to my eyes, I'm like, look, I'm reading the papers. I never read them before. I'm not seeing it. I mean, yeah, there's some good evidence that the amount of energy can be explained that way. And then they say, what about the spectrum? I look at the papers. I say, well, you know what? Your papers to explain the spectrum of the sun, it's a lot of hand waving. In fact, there's some mathematics in there that, I mean, I'm kind of middle of the road mathematician. I'm like, look, this math is pretty iffy, right? That you're saying anyway. So there's a lot of stuff that just doesn't sit well with the current model. And so, if you can call it, did you get any images?
I for some reason I'm not able to put it up, but here's what I will do: is if we want to look at it together, and then I will impose it into the.
Perfect.
I'll do it in post.
That's totally perfect. Right. Okay. So then Herschel telescope and Planck telescope go up. I think it was 2008 or something like that, that they go up. These are telescopes that they send into space. I mean, if you want to be amazed at the skill of humans, look into the engineering of these space telescopes. It's just staggering how good we are at some of these things. You put the telescope there, and then it starts sending back images, and the images that it sent back are nothing like what our eyes see. So our eyes, when we look at the sky with our eyes, we see a dot of light and then black, and then a dot of light and black. So our eyes show us this lonely cosmology that we all learned in school. And then the Herschel and Planck telescope starts sending back what they see, and they're actually looking in longer wavelengths. So longer wavelengths than our eyes can see, right? Infrared, microwave. They're looking at longer wavelengths, and the entire galaxy is filled with filaments, and all the stars reside on filaments. It's literally like a giant tree or a picture of the brain or something. And so that when I saw those, then it was like, okay, all stars are connected. They all live on these giant tree structures. There's things in there that we have no idea what they are. Literally, we're looking at organs or something. So that to me was kind of like on the evidence side.
Okay, no, I think that when you start to see those patterns, you have to look at that and say that is not random.
No,
there's no way that those stars can line up the way they do, and those all right on those filaments, and what are those filaments even doing? These are all questions that.
Yep, exactly. What are they doing? What are they made of? You know what they're made of, Mike? I'll tell you what they're made of. They're made of organic molecules.
Okay.
Now, isn't that a little mind-blowing?
That is kind of mind-blowing. All right.
And they're also made of silicates, kind of like in cows, like our bones. They also have stuff like our bones. They have so many organic molecules, just hundreds. It's really, as you can imagine, it's somewhat challenging to point a spectrometer out into space and look at the spectrum and deduce what's in it. It takes a lot of time, a lot of intelligence, graduate lifetimes, et cetera, et cetera. But there's no end to the molecules we're finding. It's like every organic molecule you could imagine. There's even a Japanese group published their analysis. They were finding amino acids. Do you know what an amino acid is? It's the building blocks of our proteins.
Right.
They're saying there's amino acids out there, and it's like, boy, I mean, come on.
Well, and oh man, I think there would be some people, even with this kind of evidence and even more evidence. I mean, we could talk about there's the Northern Lights. We could talk about where lightning comes from. I mean, there's so much that we can talk about as far as evidence that potentially could point to. Well, it definitely points to that electricity plays a much larger role in the universe than what the standard model predicts.
Yes. Yeah. And me and the guys I do research with, that's not even a question for us anymore.
Yeah.
And I'll get in trouble sometimes. I'll be in a conversation at a symposium or something, and I'll just say the wrong thing. And it's like, what do you mean there's electricity in space? And I'm like, oh, that's right. You don't know that there's electricity in space.
Which is insane because it's there. Like it's not hard to find if you're looking for it.
Yeah, it's pretty amazing.
So, but I think even in light of a bunch of evidence, I think there would be many scientists that would stop and say, well, this is a Goldilocks universe. We already knew it was a Goldilocks universe. We already knew that we live in a universe where life actually exists. We live in a universe where, everything has happened to magically line up in such a way that allows for all these, magnificent sights and how nature works. But that's just one of, of course, when this multiverse idea that of course, if you have, multiple universe, if you have an infinite amount of universes, that one is going to look like ours, right?
Yeah, right. And we're in it. Yeah.
We just happen to be in that one, so, tell what do you think about that idea of the multiverse and
right. Well, you just said, I like it in the sense that it really makes your mind go places, right? Mm-hmm. Just what you said, when you hear the argument that you just vocalized, your thoughts are kind of like, oh, whoa. However, having said that, so we live in a universe where, I'm just repeating what you said, where everything is so finely tuned. Like if, I forget the papers, but someone went through and said, if electricity, instead of being, 10 to the 39 times stronger than gravity, if it was 10 to the 39 plus, 0.4 stronger than gravity, then none of this would work. So that fine tuningness, I think it might be some other faculty in us that perceives that it comes from a plan, that comes from mind, that comes from intelligence, that comes from even beyond intelligence. It comes from some level of consciousness that we just can hardly even imagine. Can you imagine the level of consciousness needed to set up the laws of a universe? I mean, no, that's right. So if you have a purely materialistic mind, if you're a positivist, then you just say hogwash, talk to my oscilloscope, right? Because that's the only language I understand.
Right,
and then me and you and others, I don't know, it's like we have another organ in us or something where we perceive, I actually perceive that the world is filled with this incredible consciousness and intelligence. And I don't know I can't convince anybody who only trusts their telescopes and their microscopes. I don't know how to convince.
Well, it is difficult. I think, I think a couple of things. Well, number one, the closer you are to dealing in real things, if for instance, we were talking earlier about Brett Weinstein and the Rogan podcast, where this kind of idea came up
Yeah.
in that show. And Brett was skeptical of the multiverse, and I think it's partly because he deals with real things. He's a biologist. He deals with things that he has to like actually falsify in a real way.
Yeah.
He has to,
Yeah.
and I think about like my father, who's an electrical engineer, and many electrical engineers are involved in the electric universe because like they build things, they make things, and
Yeah.
they have to make things work. And it's not just math and theory.
Yeah. So, yeah. So let's talk a little bit about this multiverse ideas.
Yeah.
So, what I have been taught is that possibilities exist. Now, this is a strange idea. This my guitar pick exists, right? But there's also possibilities for all possible guitar picks. Where do those possibilities live? They are real. They exist. I think they were created. So all possibilities for anything, for you, for me, for our country, the possibilities exist. And so that, you could say, is the multiverse, is all possibilities.
Right. The future is open-ended, maybe.
Yes, right. The future is open-ended. And what's that Beatles song? Nothing you can sing that can't be sung.
Right.
So, right, there's certain things that are impossible because the possibilities literally do not exist for them, right? And those things can never happen, will never happen. But anything else that happens, it's fulfilling some possibility. Now, I'll bring it back to biology. If we look at our DNA, whatever that mysterious molecule is, it has so much information in it, right? So what was after the Human Genome Project, which I applied for a job at and got shut down?
What?
Yes. So
boy, did they miss out.
they identified, like, whatever it was, 3%, 2% of the genome, right? And they said, here's the genes. By that they mean here's the things that code for proteins and for control of control. And the other 97% is junk, right? So people like you and me were like, no, I don't think the other 97% is junk.
Right.
I just don't think so, right? And so this genetic code, it's in every one of your cells, which means all possible cells that you can ever have in your body somehow come out of that. And you can never give birth to a cell that belongs, to an Inuit Indian. It cannot come out of your DNA, right? But all possible cells that can be in you are somehow, it's a complete mystery. They somehow are in that realm of this molecular, almost infinitely complex molecule, and they can come out. So it's like there's the multiverse exists in possibility. I'm kind of repeating myself, possibilities. And then you live your life. I may live my life. We make choices. Accidents happen to us. Maybe we work our body. Maybe we work these skills we have. And the DNA responds. The DNA somehow allows you to produce calluses, freaking calluses on your body, right?
Yeah.
Like what? How does that happen? Oh, it's just the DNA,
Somehow nature knew that we were going to be guitar picking fools.
And the old humans, they couldn't grow calluses and they wouldn't play guitar. So nature was like, okay, we got to figure this out.
Exactly. I love that concept because it's almost like, the old kind of particle wave theory idea. Like as we get closer to, as we make choices in life, as the universe kind of works its way through as it does, as the future becomes closer in the present, it like collapses into what it is.
Yeah. Which is an utter mystery.
Yeah.
Most of us have a sense of what's possible in the future. I just love this, that, we have this intuition or what, and it's very simple. It could be like you're out driving and you see a car start to whatever, move, and you're like, okay, it's quite possible that person's going to cut me off, right? Just ordinary stuff.
Right.
We have this ability to see what's possible, and either go for it or avoid it, or what. I had an interesting experience recently. It's been a while since I've had this strong. I was coming back. So the SAFIRE group, our main lab is up in Canada, north of Toronto. And so I spend a lot of time up there doing experiments. And so the long weekend here, Labor Day weekend up there, coming back, of course, the flights get canceled. And I was able to jump into an Uber and boogie to another airport and get a ticket last minute and fly a propeller plane over, to Boston. And it was all very strange and exciting. And I could feel that my timeline had split. And I could kind of feel that I was still in Toronto, but I wasn't in Toronto.
Right.
It was a wild experience. And I'm like, this is not imagination. Like this. There was like a split. There was a fork in that road.
No, no, that is really interesting. And again, those are things that, like, if you think about your life, you can identify experiences like that, or when time stands still for a moment, when you don't understand, how it speeds up at times. I mean, and it makes me think. I was having a conversation with my dad again about like this amazing organ, the brain, that we have, and what its real purpose is, and is it really this like all encompassing thing that controls everything, or is it more of this receiving station, that how we connect to each other, connect to the world?
Yeah.
Things we just don't understand.
Yeah.
And it may actually makes me think of one of your video essays where you talked about the role of supernova. What's the function? What is it doing? And you had made this beautiful statement about how, like the brain, if we look at a brain scan, you pick up a cup and certain parts of the brain turn on and off, and we can actually see that happening. It's still a mystery, but we see those things happening. Yeah. And in the same way, you propose the idea that maybe that's what's happening in the galaxy or the universe when electricity is this great change agent, and when change happens, maybe it's turning on certain things to do more work.
To do more work, exactly. Yes, to take on greater responsibility, even. Yeah.
I'm so curious, because it's such an original thought to me. Like, where did those ideas come from? For you?
Yeah, I've inherited a lot of really great ideas. I've had really good teachers who are very knowledgeable of, knowledge going back, ancient knowledge, all of Plato, all of the Bible, all of Shakespeare, all of the Egyptian text, just all that. And then I put a lot of work into making it mine. Right. It's a lot. I put a lot of work into it, but I'm not, so to speak, the originator of the ideas, if that makes sense. Right way to put it. But so for example, the thought that supernova are taking on more responsibility in the galaxy. Right. So that's not my idea. That idea goes way back. Early Christian thought says that angels can become archangels, right? And archangels can become, so there's this natural thing in the created universe where anything and everything has the possibility of taking on more responsibility in this universe.
And we see, again, like I want to be really clear, because sometimes we can talk in these terms and it can feel a little new agey, can feel a little ethereal, kind of out there. But I mean, there is great evidence that this is exactly what's happening. One of the things we talked about DNA and the purpose, what DNA does, what the genes do, and then you think about like, okay, well, what's the role of electricity in activating those, and how does it know what form to take? How does it know what to do? That's a crazy mystery.
It is a crazy mystery. It really is. Yeah. Yeah. And I'm noticing some other I guess mostly biologists that I'm reading, who are starting to acknowledge that what we think, what's in the textbooks that says DNA is this, like this is what DNA is, we got it all wrong. We really got it wrong. And that this thing that you see, the double helix thing you see with the codons on it, that never really exists in any of your cells, except for maybe at the moment where the cell is dividing, maybe. But like for living ordinary life, it's not like that. All of the strands are all packed together and all next to each other in these spirals within spirals within spirals, and it, that's not just for the convenience of packing, right? It is somehow directly related to how that world of DNA relates to this world that I'm looking at now with my eyes outside of me. I don't know if I can say much more about it right now, but I'm just saying I'm noticing a change. In fact, there was an article in one of the big journals recently that said the headline was "DNA does not control our development." I was like, finally, right? Finally, someone said it. Someone said it and got it published.
That's great. No, yeah. There is going to be a point where it's amazing how many excuses can come out, but where the excuses run out, where we have to acknowledge, there probably is no such thing as dark matter. There probably is no such thing as dark energy, whatever that is. These ideas that have been just globbed on.
Yep.
And
pretty embarrassing. Yeah. Cosmology is broken. Cosmology is completely
broken.
Yep.
It is. And sometimes I think it's the trickle down effect where people realize that and then it can filter down. But to me, like what's happening, what I've seen with the electric universe community, and it's almost like a trickle up effect. It's a it's a grassroots idea.
That's a great way to put it. Yeah, I agree.
You're having lots of
recently that astronomers geophysicists are surprised that the entire Earth has an electric charge to it. I'm like, well, if you could have come to one of my talks 8 years ago, I could have explained that to you, right?
Oh, it's wild. It's wild, and it is. Let me ask you this: what do you think? Is it pure funding? Is it pure hubris? I mean, why are people so reluctant to embrace electricity, its transformative power in the universe, and the work that it does?
Yeah.
What's the holdback?
Yeah, exactly. I think about it a lot because I swim in that a lot, and so I know that there's a part of it that has nothing to do with science. It could be techniques for shooting pool. It could be politics. It could be how you fix a Volkswagen. That it's and I don't know where it comes from, but it's a human trait to kind of like get your thing and get your buddies and get things set. And then anybody who challenges that, you attack them. I don't know where that comes from, but that is so human. It's just like,
it's so tribal.
Tribal, maybe, right, exactly. Tribe stuff. But I don't know, why wouldn't the tribes be healthier if they learned from each other? Do you think that would be healthier?
You think?
Yeah, so there's something in us, and maybe let's circle back to it maybe if we want to. What is that something in us? But then there's also the part about with the science. Okay, so the scientific part, what it seems to me is that there's a certain type of person that goes into science who wants to deny there's a God, who wants to have power, who wants to destroy, who wants to erase beauty and shoot things into us to change our genetic makeup,
right?
Modify the corn. There's some that's a thing, and we where does that come from? Right?
To be a god thing. Like unto ourselves, to
say again.
To be our own God.
To be our own God. And so when that comes up against the electric universe cosmology, which says we are part of a larger world that's part of a larger world that's part of a larger world, etc., and that we are serving that larger world, which is serving its larger world, which is, that goes right against that, whatever that is that wants to tear down and be God, and it's vicious. That's part of like the clue for me, is that whatever that is, it is vicious and it will tear your throat out, because it cannot support that there could be something more intelligent than it,
Right.
or more loving. But I don't even know if they think that way.
Right. I whenever we talk about this kind of stuff, I always think back of again, C.S. Lewis and That Hideous Strength.
Yeah.
And there's that really famous scene where the scientists are, they think they've done this wonderful thing by animating this head, and they're all prone talking to this head, worshiping the head and thinking that it's their own doing, and the head is this demon, and they don't realize like what they've actually done.
Yeah.
And this the complete they're absolutely blind to what is really happening.
It's amazing that he was visionary, right? It's amazing that he brilliant. And that's it. I totally agree. I
think that particular book, but that whole series is fictional prophecy. I mean,
exactly right.
It's just amazing stuff. I want to talk a little bit about the SAFIRE Project, because there was a lot of talk in the community about it a few years ago. It is still, I think, one of the most exciting adventures and ventures that has happened, definitely in the electric universe community, but I think in science specifically. There is, I as a guy who's not a scientist, but loves science fiction, I could just imagine the possibilities that the SAFIRE Project can bring. Talk to me about your what you're doing in that project, how you're affiliated with it, what it actually is, if you don't mind. And then what are some of the things that you're working on that you can talk about?
Cool. That'd be great. Yes. Yeah. So it started in 2011 or 2012. There was this wonderful family, the Mainwarings. I don't know if I should say their name. And they cared deeply about science and about the history of science. And they wanted to know, is there a way that we can do a laboratory experiment that will show or like prove or disprove this whole electric universe theory of suns, right? Very audacious, very daring, very exciting. And it was one of those, we don't even have a word for it, right? Like, I happened to be at the right place in the right time, and I happened to shoot my mouth off in totally wrong circumstance, and I happened to, do all these things such that a week later I got a phone call saying, "Hey, Michael, would you like to be on the SAFIRE Project?"
A little serendipity, maybe. That's great.
And so I was, I was largely responsible for the scientific aspect of it, and as you can imagine, it's also a very challenging engineering project. The main chamber we worked with had something like 45,000 parts on it, right? And so
and the idea was to create a mini sun. Like how would you describe what
create a mini sun? And so what we ended up doing was part of the electric universe idea is that the sun is an anode, meaning it has positive charge relative to its environment. So all the planets are negative compared to the sun. And this is now known, even though we knew it a while ago. But anyway, and so there's this electric discharge that's happening on the anode sun. Okay, so we made a chamber where we could do that. We could make the center of it an anode, meaning it has positive electricity in it. And then we light it up like a fancy fluorescent light bulb or a fancy lightning strike or something, right? It's electric, lightning, it's a glowing ball. And then we can switch it so the cathode, the other pole, is in the middle, and then you can see that, no, that doesn't work. So we've kind of verified that, yes, it looks like a sun if you make the center positive, and it just doesn't look like a sun. So that's kind of like just your eye seeing it. And then on the more quantitative side, we maybe afterwards we can also find some images of the photosphere of the sun that we can put up right now as we're talking. So the photosphere of the sun they're called granules. They're these things that are right next to each other like cells, but they're very dynamic. They keep appearing and disappearing, right? And so we were able to make something that was kind of like that, not exactly like that. We called them anode tufts after the Russians. The Russians coined that term back in the 60s or something. So these little teeny like dots that cover the anode.
Right.
And those dots that cover the sun, again, you look at the original papers, there is no way to explain those dots if you believe that the heat is coming up from the bottom, from the inside of the sun. And if you believe what the physics tells you the density of the photosphere is, it's like, no, sorry, you don't get that, right? You just don't get it. Anyway.
And just a simple, like for people, that if you're curious, go look at the sunspots on the sun and ask yourself, why is it dark? Why is it black? Because if the heat was coming from inside the sun, it shouldn't be black.
Right. And you can look at the papers that address that. So this is what you're saying about trickle up. So the electric universe people threw that back, at the community, just what you said, right? And then after like 5 years or so, a few papers came out, showing that there's nothing to see here, folks. It's we can explain it by toroidal twisted magnetic fields or whatever. Okay, I mean, if you can understand the math behind that paper, woo, good, good.
Well, that's the point. You're not supposed to. You need to ask the high priest of math to explain it to you.
Right. But they had to address it because, there was grumblings, right? So what was I saying? So, and then also there's a mystery to the sun's atmosphere, our sun's atmosphere, where the temperature, and I'll define what I mean by that soon. The temperature increases as you move away from the sun. Now, that doesn't seem to make sense, that as you move away from something, the temperature goes up. So this is a mystery. It's pretty much acknowledged still as a mystery by mainstream astronomy. And so we were able to find that if we do our little electric sun and we measure temperature the same way that NASA measures temperature, then our temperature increases as you move away from our sun. Boom, right? Very cool. Very cool. The effect wasn't enormous. On the sun, the effect is enormous. It's just baffling. It goes from like 10,000 degrees to 3 million degrees. And it's like, what? But our effect was unambiguous. It was obvious. It was clear that as you move away. And then also the sun has these coronal mass ejections where material kind of lifts off the sun and then goes kapow, and it accelerates literally like a gun being fired. They're called coronal mass ejections. That's the Carrington event, the thing that hit Earth in 1859 and wiped out. Right. And so we also had coronal mass ejections in our little sun. Again, they didn't look exactly like it, but you're watching it and you see a part of the anode kind of like thicken and kind of grow dense. And then it goes boom, and it just shoots out towards the side of the chamber.
Wow.
And then the last thing was, and we weren't even looking for this, the last thing was that we have elemental transmutation in the chamber. And so we tried a variety of different materials, like maybe have a tungsten anode and copper cathodes. How about an aluminum anode and steel cathodes? How about a nickel, so we tried these different metals, right? And we were always very careful about what was in there. We measure what was in there with EDX, and then afterwards we would look at the materials, and always there was all this other matter had appeared: calcium, titanium, sodium, phosphorus, carbon, sulfur, magnesium, manganese, and so we were like, well, you know what? That's maybe where all these elements come from in solar systems, is they are being made right on the surface of the sun.
Wow. That is incredible. And again, I can't help but think like the possibilities of, running that experiment, seeing what that happens, having that work just as it you would expect if it were a sun,
Yeah.
It's remarkable. It really is remarkable. So, what's the status of Sapphire? Like what's going on now? And
Yeah.
because it's been a little bit quiet, but I know you guys have been working.
Yeah, exactly. Right. Yeah. And that's partly our fault for, we're primarily scientists rather than PR people. So we completed the mission that the Mainwaring Foundation gave us to, can you run some experiments in a laboratory that will either, support or deny the model. And so we finished that, and that was the end of that. And then it became, now what do we do? Do we close up? Do we go home and do other things? Quite certainly a possibility, right?
Right.
And then we met some people who know some people who know some people. And we realized, oh gosh, we can use our technology to try and remediate nuclear waste, radioactive waste. So if we can turn, a heavy element like thorium or something, if we can turn that into lighter elements like aluminum and copper and calcium, and then maybe
sorry, I have to think of like Newton, like right now, like and what's it called? Turning lead into gold. Come on.
Oh yeah, alchemy.
I mean, come on. I mean, this is like, wait a sec. What are you guys? You guys are like fulfilling Newton's love. That's wonderful. Okay, so if you can take these heavier elements and transform them,
yes, then let's see if we can clean up the radioactive waste that's all over the place. Because if you have a big radioactive element, right, like cesium-137, it's big and it's given off nasty stuff, and it's a nasty thing to have in your backyard, right? If we can put it through our process and we can turn it into we call them benign daughter elements. We can turn it into benign daughter elements, then like, whoa, let's do that. I mean, that's a great idea. So that's what we've been pursuing for several years now, is how to do that. And luckily something has changed at the level of institutional and governmental science. So it just as recently as, when was the last time we talked to them? We talked to the nuclear agency in the United States maybe three or 4 years ago. And they were just like, go away. We do not want to hear you about your solution. And it was very confusing and kind of upsetting to me and to the team, but it really kind of affected me deeply. And then I talked to somebody high up in the Army who, friends of one of our scientists. And he's like, Michael, you are so naive, right? He said, why do you think they didn't want you to clean up their nuclear waste? And I'm like, I don't know. And he's like, because they look at it and they see future bombs.
Yep.
And I was like, oh shit. Yep. I was pretty naive, wasn't I? Right?
Yeah.
And then as recently as a year and a half ago, something has 180'd. And now the US government is asking for research projects that can do low energy nuclear reactions, like what we're, to clean up nuclear waste. And they have money, they want to spend money, and they want to solve this problem.
That is insanely cool. I mean, like that, because one thing leads to another. Technology builds on itself, and doing these kind of high end, like really important projects, like nuclear waste. I mean, to me, that just, again, it's going to trickle into other things. Other things are going to build off that, and and again, my mind always goes, starts to thinking like, man, it'd be great if everybody had their own little sun in their home, and I don't know how. I mean, Tesla is like, Nikolai Tesla is such a mystery to me, and I think to a lot of people. Yeah. But he had some ideas that he was right about, and I think the more we explore like how much energy, how much power is actually just, I won't say inert, but it's sitting there ready for us to do something with.
Yeah. Yeah.
And we just need to figure out how to do it.
Yeah. Yeah, exactly.
Because really we have in a real way, because we are connected to the sun, the more you start to realize, like, we have the entire power of the sun at our disposal. It's wild to think about that.
It is wild to think about that.
So, again, like Dr. Clarage, I would love to have you on again. There's so much more we can discuss. I mean, we didn't talk about, there's a lot. There's so much.
Yes.
I would love to have you on again. I really appreciate your time.
Yeah, you're very welcome. Yeah, this can be talk number 1.
I would love it. I would love it. Well, tell me, so just best places for people to find you. Substack, just look up Michael Clarage.
Yeah, michaelclarage.substack.com is probably the best place. Yeah. And then, like you said, the plenty of good work up on YouTube on the Thunderbolts channel on YouTube has some really good stuff of mine. And then, like my talk with you here, I have a variety of other things scattered around. But
I think people want to check those 2 things out. I think they'll get a good feel for who you are and your ideas. And so again, I really appreciate it. And again, I'd love to do it again. So thank you so much, Michael.
You're so welcome.
Mike is gone.
You are listening to And If Love Remains.
Gone but not forgotten.
First of 23 installments requested by Dr. Levitt. Trying to be in compliance here because we're taking him and that whole organization down.
Speak peace like a Buddhist.